Follow up with page 64, number 4. So one of the things you were supposed to do on number 4 after you measured the sides was find the perimeter. And let's look at 4 different examples that students have gotten in past classes. So there's 4 different answers. Which one of those students is correct? Well, it turns out that they're all correct. And you might wonder how that can be. Usually in math class there is one exact answer. Well, the problem with this is that these numbers came from things where we actually measured the sides instead of being given the actual values. And anytime you have measurements, you're going to have some people who disagree with those measurements. So the measurements are what we call approximate numbers, not exact. So even though these numbers are all different, they are very close to being the same. Now, as mathematicians or scientists, we always agree that the last digit that's written is where we allow there to be some differences in how we evaluate those numbers. But these numbers should all agree. Every now and then you'll have a number that is very close to 24, like 23.9, and we would say that that agrees as well, because if you rounded it off it would be a 24. But most of the time we just look for the disagreement to be in this last place. So let's take a look at how we find the perimeter first. So the first thing we need are some measurements. So side AB, I measured to be about 8.4 centimeters. So you should look at your measurements and realize that you could be off by 1 or 2/10 of a centimeter when you measured that. BC, I measured to be 5.7 centimeters. And AC, I measured to be 10.2 centimeters. Then to find the perimeter, we need to add up all those measurements. Notice that since they're measurements, I have units in my expression, not just the numbers themselves. And if I add all that together, yes, I use my calculator. I don't try and do this in my head. That answer is 24.3 centimeters. All right, since that's an approximate number, again, we're going to get different results, but we want it only to disagree in this very last decimal place. Then we should talk about where we would want to round that answer. Now, we said already that the answers that the students were getting were only disagreeing in the tens place, so it seems reasonable to just keep these numbers rounded to the tenths place. And you should remember from the prep assignment that you did that that is the rounding rule for perimeter. For perimeter, we round to the tens place or to the least precise decimal. With the least precise measurement. So what do we mean by that, round to the least precise measurement? Let's suppose somebody gave you a triangle. Imagine that's a triangle. And they very carefully measured one side to be 2.25 meters and another side to be 5.86 meters. And for some reason, they did not measure this side as closely, so they measured it to being 4.3 meters. So if I'm adding those numbers together, and I do that on the calculator, if you write down 12.41 on your paper, you're going to get a nasty note from me. Okay, maybe not really nasty, but I will write a note to you because when you measured to this side, this 3 is approximate. Somebody might have measured it as a 2 or a 4. So when I look at this answer over here, this tens place is questionable. So I don't want to write down 12.41 if I really don't know the tens place that well. So what we'll do is we'll round to the least precise decimal, and the least precise decimal is here in the tens place. So I'll round my answer to 12.4 meters, because I know that it's in this place where some error could have happened over here with my measurements. So when you're rounding for perimeter, look for the least precise place value. All right, let's take a look at some of the area answers. So some of the answers for the area for the triangle that I've gotten in the past are 23.46. I'll talk about units in a minute. 23.97. 22.725. So that doesn't even end on the same decimal place as the others. And 23.69. So even if I dropped this 5 off and rounded it up to a 3, you can see a lot of places where these numbers are disagreeing. In fact, the only place that they totally agree is in the tens place. They're already starting to disagree in the ones place, and then they disagree more in the next couple of decimal places. So it turns out that we're not going to use place value to round area. And again, this is something that you saw from your reading, the way we're going to do it, but let's walk through this first example anyway. In order to get the area, you had to know the base of the triangle, and the base of the triangle was side AC. So for this first one, side AC was 10.2 centimeters. And then you had to measure the height of the triangle as well. You had to draw in your own line there. And the height of the triangle I got was 4.6 centimeters. So to find the area of a triangle, we use a formula that says take 1/2 times the base times the height. So I'm going to take 1/2 times 10.2 centimeters times 4.6 centimeters. So we'll do that over here. Let's clear this out. And by the way, some people like to use base times height divided by 2 instead of times 1/2. That's totally fine. So pick one of those and use whichever one you like better. Some people use 0.5 instead of 1/2. Again, find the one that works for you and then memorize that one. So there's that first number, 23.46. So let's write that down. And now let's take a look at the units. I have centimeters times centimeters. And the way we write centimeters times centimeters is centimeters squared. Or you can write out in words, square centimeters. But now let's talk about the rounding rules. You know from your reading that the rule is to round area to the least number of significant digits. Now we're going to have to do a little more work to figure out all the ways that numbers are significant or not. But for right now, I'm just going to count the significant digits in our two measurements. In 10.2, there is 1, 2, 3 significant digits. In 4.6, there's 1, 2 significant digits. So since one of them has 3 significant digits and the other one has 2 significant digits, we want to round to the least number of significant digits, which is 2. So I want to round this 23.46 to 2 significant digits. So my final answer I would write as, that squiggly equal means approximately, 23 centimeters squared. Now you can see with each of these numbers that if we round them to 2 significant digits, there'll still be some discrepancy. My first one was 23. 23.97 would round up to 24. So they disagree, but just in that last place. 22.725 would round to 23. And 23.69 would round to 24. Now each one of these should also be in terms of centimeters squared for units. But you do notice that these numbers now only disagree in the last place that I've written down instead of all these other places. So that's where our rules come from. All right, let's see if we can use those rules to do problem number 5. So number 5 has to do with the circle, and they want us to find the circumference and the area. Now if you don't know those formulas, there is a place in the back of the book with geometry formulas. Eventually we'll have to memorize these, but for right now, if you've forgotten them, the formulas for the circle are on page 300. There's two formulas for the circumference of a circle. The one I like is pi times the diameter. The 2 pi r one is so close to the area that it's easy to get them confused. So I like to use this one since it's not so close to the other formula. The area formula then that I use is pi times the square of the radius. So in order to do the circumference, one of the things you would need to do would be to measure the diameter of the circle. The diameter of the circle goes from one edge of the circle to the other, or you could measure halfway and times it by 2. So when I measured the diameter, I got 68 millimeters. Hopefully you read the directions very closely. This one said in millimeters, not in centimeters. Basically, you just take 6.8 centimeters, and if you multiply it by 10, you get 68 millimeters. And so you can use that same part of your ruler to get those numbers. So the circumference then is equal to pi times 68 millimeters. Now on your calculator, there is a pi button. So you hit the second first, and then it's over here on your calculator, and you get the actual pi symbol. I'm going to not do the arithmetic first because I want you to see pi. So this is the calculator's approximation to pi. I know some students like to just use 3.14, but that's ignoring a lot of the significant digits that we sometimes need in this class and higher classes. So please start using the pi key and not 3.14, which is not what pi is actually equal to. So let's try this again. I want pi times 68. Okay, I'm getting this very long number, so I'll write that over here. And technically this is approximately equal as well because pi is a non-repeating, non-terminating decimal, so there is no exact answer for what happens when we multiply by pi. So what sort of a rule should I use for rounding this number off? Well, since the circumference is kind of like the perimeter, one way to round this off would be to, again, to use the place value. If I use place value, 68 is written to the ones place. So I would want to write this number also to the ones place. Now, since this next number is a 6, we're going to round this up. So I would round my answer to 214. And I do need my units. My units are still millimeters. So the circumference is about 214 millimeters. It would have been okay to round this to 2 significant digits as well, in which case you would have written 210. But I'm going to leave this as 214 millimeters for right now. All right, for the area, the radius, when I measured it, was 34 millimeters. And I need to square that. So we'll do that over on the calculator. Again, using the pi key. So area, we round to the number of significant digits. And the number of significant digits in 34 is just 2. So I want to round this number off to just 2 significant digits. Now this number is 3,631.681108. When I round it off, I don't want it to be 36. I want it to be 3,600. So if this were my bank account, well, stopping here, I wouldn't say that there's about $36 in there, but I might say there's about $3,600 in there. So that's rounding it off to 2 significant digits. Again, I need to think about my units. Here I've got millimeters, but in the formula they're squared. So these are also square millimeters, which is good because area should always have square units. Now, it's going to feel awkward at first to round off a number this much. But let's suppose another student, so I'll change the color of my pen here, worked very hard at measuring, and instead of getting 34 millimeters, they got 33 millimeters. Let's see how far off their answer would be from our answer. This is just 1 tiny millimeter different. And this number turns out to be 3,421.1944. Now look how many digits disagree in these two numbers. And look at the ones that do agree, and then where they start to disagree. Well, the 3's agree, but already right here, the 6 and the 4 are disagreeing. Now, if I follow my rounding rules, I should round this number to only 2 significant digits, which would be 3,400 millimeters squared. Now I have 2 different answers that only disagree in the last place that you see one of those significant digits. The zeros here are just holding a placeholder for us. So it looks like our rounding rules are working so far. They'll take a lot of practice for us to get good at them, and so we'll end this video now and let you start some practice.